Okay, so let's go straight to our third example right here regarding the integration by substitution. So in this problem, we are to get the integral of dy over 1 plus the cube root of y. So once again, the first thing that you should do is to check if we can use our basic formulas of integration right here. But spoiler alert, we cannot use any of them from the gate, so from the get-go. So what we would be doing now is, since as the title says, we would be making use of the method by substitution or the integration by substitution. So once again, guys, if you are to introduce a certain variable, it would be up to you on which you would be substituting it. So if you want to substitute it to the whole of this, then you can do that. But in my case, I would be substituting let's say our variable x just to this variable right here, which is the cube root of y. So there. And from that, since I have this already, so for me to get the value of our dy or the differential of y, I would now be isolating y to the other side and solve for the differential of y. So from that, I would be getting the cube of both sides of the equation. So from that, this is to be x cubed is equal to y. So now that I have the value for your y, so I would just be rewriting it here. So y is equal to x cubed. So getting the differential of both sides of the equation, that is to be, so dy is equal to, so what is to be the derivative of x cubed? So that is to be 3x squared dx. So there. So now that I have both my dy and my cube root of y already, so I would now be substituting them into this particular equation right here. So this can now be written as, so what is to be our dy? So that is to be 3x squared dx. So divided by 1 plus, so what is to be this value right here? That is to be this one right here. So 1 plus x. Okay, so using this equation right here, so simplifying this one, so this is now to be equal to, so segregating this value of 3, so this is to be 3 times the integral of x squared dx over 1 plus x, or let's say x plus 1. So this is just basically this one right here, rearranged. Okay, so after that, what I would be doing is that, well, as you can see here, the degree of your numerator is higher than the degree of your denominator. So what I would be doing next is that I would be dividing this one right here to this one right here. But unlike in our previous example where I have just added plus 1 here and minus 1 for it to be more simpler. So right now I cannot do that. Well, that's what I think. So what I would be doing now is that I would be dividing this via long division. So once again, this is to be a basic algebra topic. So from that, so x squared, so using our long division right here, so I would just be dividing it at this side right here. So x squared divided by x plus 1. What I would be doing here is that I would be dividing this by this part right here. So x squared divided by x, so that is to be equal to x. So x times x, so that is to be x squared. Then x plus 1, this is to be plus x. So subtracting this value right here, so this would just be equal to 0. And this is now to be equal to negative x. So from that, negative x divided by positive x, so that is to be equal to negative 1. And negative 1 times x, that is to be negative x, then negative 1 times positive 1, that is to be negative 1. So subtracting these values right here, this is now to be equal to 0, and this one right here is equal to positive 1. And since we cannot divide 1 by x, so what we would be doing is that we would just be adding our remainder here. So this is to be our remainder, so plus 1 divided by our divisor, which is x plus 1. So this is to be our new value to be written in this part right here. So from that, once again, this is to be our new equation. So this is now to be equal to 3 times the integral of x minus 1 plus 1 over x plus 1. Well, d of x. So from that, I would now be simplifying this one right here. I would now be rewriting it like this. So this is to be 3 times the integral of x dx minus the integral of 1 dx, or just the integral of dx, plus the integral of dx over x plus 1. So what I did here was just to distribute this value of dx right here to all of the terms. So I would just be writing this one right here for it to be more presentable. So here, okay, so from that, let's just solve for the integral of all of the terms. So this is to be equal to 3 times what is to be the integral of x dx. So using power formula, this is to be x squared divided by 2. How about for this? So what is to be the integral of dx? That is just to be equal to x divided by 1, or just simply x. And as for this one right here, so we can actually use our logarithm formula here, since in logarithm formula, the integral of du over u is equal to the natural logarithm of u plus c. And as you can see here, our u is equal to x plus 1, and our du right now is to be equal to, so what is to be the derivative of u? That is to be just dx. And as you can see, the derivative of u is just to be this one right here. So we can just use this one instead. So from that, our answer here would be, so positive, the natural logarithm of x plus 1, since x plus 1 is to be our value for u. And don't forget, guys, the arbitrary constant c, so plus c. So there, and from that, once again, distributing 3 here, so this is now to be equal to 3 over 2 x squared minus 3x plus 3 natural logarithm of x plus 1 plus c. And 3 times arbitrary constant c is still an arbitrary constant, so plus c. So there. And once again, guys, don't you forget that this answer right here is actually the answer of our transform equation, which is to be this one right here. So what we would be doing next is for us to substitute these values right here to divert it, to redivert it into this kind of equation, which is in terms of y. So from that, I would just be copying this once again. Okay, so substituting this value of x right here to this equation right here, our answer would now be equal to, so I'll just be dividing this one right here. So our answer right now would now be equal to, so 3 halves times x squared, and what is to be our value for x? That is to be y raised to 1/3. So y raised to 1/3 squared. So 2 times 1/3, that is equal to 2/3. So that is for our first term right here. So minus 3 times x, and our x once again is equal to y raised to 1/3, or the cube root of y. After that, plus 3 times the natural logarithm of x plus 1, and our x once again is equal to the cube root of y. So y raised to 1/3 plus 1. So plus 1 plus our arbitrary constant c, so plus c. So the answer of the answer of this equation right here, so I would just be moving it. So from that, the integral of dy divided by 1 plus the cube root of y is equal to 3 halves y raised to 2/3 minus 3 times y raised to 1/3 plus 3 times the natural logarithm of the sum of y raised to 1/3 plus 1 plus c. So this is to be your answer for this particular problem.